there is a difference, or if you didn't print them, that's with significant digits. So if we look here, we have this idea of exact versus approximate. So when counting objects, an exact answer can be obtained. To find numbers such as 12 inches equals 1 foot, or 1 inch equals 2.54 centimeters are also considered exact. Any physical measurement that you make is only an approximate value. So when they're saying any physical measurement, they're talking about like you get out a ruler and you measure how long it is. That's an approximate value because it's not an exact amount. The significant digits in a number are those that represent an actual measurement. To determine the number of significant digits, we follow these rules. Now, I will warn you, when you're doing this homework, I highly suggest having these rules sitting out, because it takes practice doing these in order to like get down the process and know that what you're answering is, or like that you're rounding accurately based upon the rules is what I'm trying to say. So you're going to have to look back at these rules a few times in order to get them. Rule 1 says digits other than 0. Oops, this should be in than, not that. Other than 0 are always significant. A 0 is significant when it appears between two significant digits. So let's say we have 305, that 0 in the middle would be significant, or 0.706, that 0 would also be significant. The 0 is at the right hand end of a decimal number. So say 0.50, that 0 is now significant, or is marked with as significant with an overbar. And so you might have something like 0.60, actually, yeah, let's go with, you might get something like 500, and they'll put the overbar there over that 0, which would mean that we have two significant digits there, the 5 and the 0, but the last 0 is not significant. When is the 0 not significant? When it's the right hand of a whole number. So 500, these two zeros, not significant. And then it's at the left end of a number. So if I have 0.6 or 0.06, both of those zeros are not significant. Again, it's going to take practicing these rules and using them in order to become familiar with them. The precision of a measurement number is indicated by the place value of its rightmost significant digit, and the accuracy of a measurement refers to the number of significant digits it contains. For multiplication and division, the answer should use the number of significant figures or digits from the number with the least significant digits. And then, so this would be for like rounding purposes. And then in addition and subtraction, the answer should use the number of decimals from the number with the least number of decimal places. So this first set of numbers, we're going to look at just identifying how many significant digits there are. So if we look at number 1, we have 12.020. So because this 0 is between two whole numbers, it's significant. And because this 0 is at the end of a decimal number, it is also significant. Therefore, we have 5 total significant digits. When we look at number 2, 0.0020, these two are not significant because they are to the left hand of the number, but these, the 2 and the 0, are significant. Again, it follows our rules that any number not equal to 0 is significant, and a 0 at the end of a number is considered significant. Therefore, this is going to give us 2 significant digits. In number 3, we have 2,200. Again, the 2 2s are significant. The 2 zeros, not significant. because they follow the rule that it's at the right hand of a whole number. So again, we only have 2. Now, when talking about zeros being at the right hand of a whole number, if I have the number 1000 and then they put a decimal point at the end, this is indicating that it is a rounded answer, and therefore this contains 4 significant digits versus the number 1000 with nothing at the end only has 1 significant digit. So then we want to use our rules of rounding. So number 4, number 5, we're going to do addition and subtraction. So the first thing we do is we always just we just perform the operation as it is. So if I take 12.456 and I add 2.1 to it, I get 14.556. Now, if we go back to our rules for addition and subtraction, the answer should use the number of decimals from the number with the least number of decimal places. So because this one only has 1 decimal place, and this one has 3, our answer, again, must only have 1. So we need to round this, which gives us approximately 14.6. or an answer with 3 significant digits in it. So I want you to go ahead and try number 5. So number 5, when I add these together, I get 372. Because there aren't any decimal numbers, we don't need to worry about rounding this number off. We would just leave it as 372. And again, there's 3 significant digits in the answer. Now, number 6, we're using multiplication. So we're going to do 12.456 times 2.1, giving us 26.1576. Now, again, now when we multiply, if we go up to our rules for multiplication, the answer should use the number of significant figures or digits from the number with the least significant digits. So what they're saying is that looking at the 2 numbers that multiply together, which one has the least, and that's how many your answer should have. So this one has 2, and this one has 5. Therefore, our answer can only have 2 significant digits. So rounding this, we get approximately 26. So go ahead and try number 7. Again, make sure you round to the number of appropriate significant digits. Okay, so if we multiply 330 times 42, we get 13,860. Now, both of these only have 2 significant digits. 330 has 2 because it ends in a 0, so we don't count that 0. So this, when we round this, it becomes 1,400 or 14,000, excuse me, and therefore has only 2 significant digits. So again, we're going to keep practicing these. Go ahead and multiply number 1, and round your answer off to the appropriate number of significant digits. So if we multiply these together, 12.3 times 45.67, we end up with 561.741. Again, we have the least number of significant digits is going to be 3. Therefore, we have approximately 562 as our answer. Switching back to addition. So remember, with addition, you're going to add these together, and then your answer has to be rounded to the least number of decimal places as the numbers that are used. So go ahead and do number 2 and number 3, and we'll talk about them. So number 2, if we add these up, 4.205 plus 2.0 plus 3.0557, we get 9.2607. Because again, we're using addition, we have to go with the least number of decimal places, which is 1 decimal place. And so we would round to 9.3 here. For number 3, 2.2 plus 3.34 plus 4.567 gives us 10.107. Again, we need to round to 1 decimal place, which gives us 10.1 as our answer. Instead of doing number 4, I want to add one in. And this will be a new number 5 instead. So number 5 has 5.62 times 4.63 plus 5.67. So why this is important is that we are now using 2 different operator rules, meaning we're going to have to use rules of multiplication and division and rules of addition and subtraction. So multiplying first, 5.62 times 4.63 gives us 26.0206. And we're going to say plus 5.67. Now there's this thing called an underbar. So if we thought about when we multiply these together and we want to round the multiplication. Again, with multiplication, we're looking for the least number of significant figures. Since both numbers have 3 significant figures in it, our answer can only have 3 significant figures. So I'm going to mark the 0 with an underbar, and that underbar indicates how accurate this number is. Meaning, so yes, we have 26.0206, and we're keeping that as it is. But when we go to add these together, it tells us that our first number is only accurate to the 10th position, and therefore we're treating it as only having 1 decimal place for purposes of rounding. So again, we're going to leave the whole number, but we're going to now add 5.67 to it, giving us 31.6906. Again, because we can only round to 1 decimal place, we're going to end up with an answer of 31.7 as our final answer. So that's where, when we're doing multi-step operations where they have multiplication or division and then addition or subtraction, you've got to indicate, when you simplify one type of operation, meaning like the multiplication here, we have to indicate how accurate that answer is, so that when we go and perform a new operation that has a new set of rules, we know how to round with those 2 numbers in the future. Okay, so that's why we use that underbar. Okay, so switching gears to the metric system. So the basic units of metric system: length is meter, the weight or mass is grams, and volume for liquid measurements is going to be liters. So when we think about the metric system, we talked about powers of 10 already, right? We did scientific notation just on Tuesday, right? So when we think about our unit of measure, so we've got our ones position right here. So let's say that we were dealing with grams. So if we go up, we would have deca, hecto, kilo. So kilograms would be our most common measurement there. And again, here's your abbreviation over here on the side. We also have a mega and a giga. But if we go down, meaning smaller, we can have deci, centi, milli. So centigrams or centimeters we deal with a lot. Milligrams, millimeters, again, we deal with those a lot. We have micro, and I want to show you that there is this weird kind of like U symbol, which means micro, or they also see it as MC, and then nano and pico. Again, most commonly we're going to be from kilo to milli, but we may get outside of those a little bit. So we've got some metric equivalents. So 1 milliliter is equal to 1 cc or cubic centimeter. And then for water only, and this is really important, you remember this is water only, 1 milliliter equals 1 cc, which equals 1 gram. Okay, and so that becomes important when we talk about the weight of liquid that a patient has taken. But again, this is only for water. That's it. Okay. And so 1,000 milliliters equals 1 liter, 1,000 cc's equals 1 liter. And 1,000 or 1 kilogram equals 1,000 grams. 1 gram is 1,000 milligrams. And 1 milligram is 1,000 micrograms. So let's do some conversions with these. So this is called dimensional analysis. So adding, subtracting, units of measure must be the same. When multiplying or dividing, units of measure do not need to be the same. In order to convert between units of measure, we need to use a conversion factor, which is a ratio of the unit you have to start with and the equivalent in the unit you want to convert to. So we want to convert 35 millimeters, to meters. Well, we know that 1 meter equals 1,000 millimeters. So we can set up this conversion by saying 35 millimeters over 1 times 1 meter over 1,000 millimeters. I want you to pay attention to the fact that our unit of measure that we're trying to cancel is diagonal. So I get the question all the time, Erin, how do I know how to set up that second fraction? What goes on top, what goes on the bottom? Well, always pay attention to whatever unit of measure you're trying to get rid of is the unit of measure that will go in the denominator of that second fraction. So we multiply through, these millimeters will cancel and we'll have 35 over 1,000 meters, which when we convert that becomes 0.035 meters. So number 2, it says 33.2 kilometers to meters. So we know that 1 kilometer equals 1,000 meters. So setting this up, 3.2 kilometers times 1,000 meters over 1 kilometer. Again, kilometers cancel. Multiplying together, 3.2 times 1,000 becomes 3,200 meters. Okay, I want you to try number 3. It says 27 micrograms to grams. So again, micrograms, we know that 1 gram equals 1,000 milligrams, and that 1 milligram equals 1,000 micrograms. So go ahead and do number 3, and let me know what you get. So in order to get from micrograms to grams, we're going to go 27 micrograms over 1 times 1 milligram over 1,000 micrograms. And then from milligrams to grams. And so we know that 1 gram is equal to 1,000 milligrams. So basically we're taking 27 and dividing it by 1,000 twice, which gives us 0.00000. Oops, do I have too many zeros there? I do have too many zeros there. There we go. 27 grams. Super tiny. So again, each time we divide by 1,000, we're moving that decimal place 3 places to the left. And so it's just going to get smaller and smaller and smaller. And we had to use 2 to get around the 2 and the 7, and then we need 4 more zeros to go the rest of the 6 times. All right, go ahead and do, I'm not going to make you do one of those crazy multi-steppy ones again. Let's just do number 5, 33.5 liters to milliliters. So to go from liters to milliliters, we know that 1 liter equals 1,000 milliliters. So we'll do 3.5 liters over 1 times 1,000 milliliters over 1 liter. Canceling, multiplying through, we get 3,500 milliliters. And if you're saying, wait a minute, how do we know that that's the relationship? Again, if we go back, we know that a milliliter is 1/1000th. And so we also have our relationship here. We know that 1 liter equals 1,000 milliliters. Okay. So let's see, let's look at these division calculations. So number 1 says 4.5 grams over 1.0 liters, and we want to convert that to milligrams per liter. So we don't need to worry about dealing with the liters. We only need to worry about dealing with the milligrams. So we know that 1 gram equals 1,000 milligrams. So we're going to take 4.5 grams over 1 liter, and we're going to multiply it by 1,000 milligrams over 1 gram. So doing this will cancel out our grams, but it will leave us with a 1 liter in the denominator, right? We didn't touch that at all, so that's still there. So 4.5 times 1,000 becomes 4,500 milligrams in 1 liter. So go ahead and try number 2. Again, we're doing 88.0 kilometers in 1 hour, and we want to convert it to meters per hour. So converting this, we're going to take 88.0 kilometers over 1 hour, and we're going to multiply it by 1,000 meters over 1 kilometer. And again, why are we doing that? It's because 1 kilometer equals 1,000 meters. So multiplying this, 88 times 1,000 gives us 88,000 meters in 1 hour. So there's one more I want to do with you. And it's this one. You do have some homework problems like this. So it says simplify and round to the appropriate number of significant digits. So it says 4.5 milliliters plus 0.0047 liters minus 3,400 milliliters. And so what they didn't say here, and it says in your homework, is equals how many milliliters or how many liters or something. In this case, I am going to have us say how many milliliters. So in order to solve this, we need to make sure that all of these units of measure are first in a consistent unit of measure, meaning they have to all be milliliters, or they have to all be liters or something. And you'll know which way you need to convert based upon the question mark of in terms of how many blanks. And so because they want them all in milliliters, we've already got 2 where we want them to be, but this one we need to convert. So we would start by first converting this to milliliters. And now remember, we know that 1 liter equals 1,000 milliliters. So we're going to plug this information in. We'll go 1,000 milliliters over 1 liter. So 0.0047 times 1,000 gives us 4.7 milliliters. So we will add these together, or excuse me, we want to first replace this and then we will add, right? So we really have 4.5 milliliters plus 4.7 milliliters minus 3,400 milliliters. So adding 4.5 plus 4.7 minus 3,400 gives us, what do we've got? It's going to give us what? Something. I don't know. What are we getting? We're getting negative 33 or 3,390.8 milliliters. Now, remember, when we talk about adding or subtracting significant figures, it's the least number of decimal places. So these both have one decimal place, but this one has no decimal places, right? Therefore, our answer can't have any decimal places either. And so rounding off, we're gonna have 3,391 milliliters. Okay. And that is our final answer. So questions about that stuff?